Hi, this is Tom Craven from RRAMAC Connected Systems. This webinar is entitled From Data Monitoring to Machine Learning, How the Industrial Internet of Things Provides a Scalable Platform for Continuous Improvement. When I talk to companies that are in the early stages of an IIoT plan, many of them tend to have a minimalist approach. What I mean by that is, first of all, they want to spend as little money as possible, and they say, all I really need is to see the value of these one or two variables out in the field, and that's all I'll ever need. Now, I also talk to companies that have gone down that path, and a year later, or maybe longer, they'll come back and they'll go, well, gee, we really didn't realize that we'd want to add these other machines in there, and the company we went with just doesn't have a product for that type of machine. Or now we want to add in predictive maintenance. We want to monitor the vibration, set thresholds, and actually predict when something's going to fail. Or automatically reorder consumables. Or we want big data machine learning, etc., etc. Now, not all companies will get to those levels, but most of these systems, once you learn a little about what's going on in the field, you find, we could use a little bit more. So you want a platform that's scalable. On the other end of the spectrum is the companies that say right out of the gates, yeah, we're going with big data. We want machine learning. We want predictive analytics. We want prescriptive maintenance. And all of that's great. The challenge there can be the timeline, because in order for machine learning to work, you have to have a very big data set, and that may take a really long time to collect adequate amounts of data. It depends on the process. But there's a lot of processes where you're not going to get enough data in a year to do much of anything. The problem there is, of course, the investors, the CFO, they may not have the patience while you sit and collect data and invest time and money to continue to do this project when it's not showing a return on investment. So the trick is to get return on investment while planning for longer term goals of continuous improvement, machine learning, etc. So in this webinar, we're going to start with information at your fingertips, not just data, but actual usable intelligence. How do you go from there to continuous improvement, predictive maintenance, machine learning, prescriptive maintenance, and then we'll summarize it all with a roadmap to get you from simple systems to the more complex IIoT solutions. So if you stop and think about the amount of information we have at our fingertips, it really is amazing. For example, if I get in my car for a long trip, the first thing I look at is miles to E. Do I have enough gas? Not just do I have a quarter tank or half a tank, how many miles do I have? And then I can look at my Maps application and know the exact mileage to my destination. And I can go, oh, I got to drive 182 miles tonight. I have 193 miles of gas. Well, I could get there and not stop for gas. Then I pull up the weather and I go, oh, the weather at my destination is going to be minus 12 at 8 o'clock tomorrow morning when I'm leaving the hotel. I don't want to start my day getting gas. So I'm going to take care of that tonight. But I made an informed decision based on available data really from 3 separate sources, all presented in a very usable format. So in that example, I'm talking about a raw material, gasoline, that's being consumed by the process, or by the car in that case. Automated equipment often has many different consumable products. I'm going to use a car wash, for example. A car wash is an automated system that uses various chemicals, sealants, cleaners, waxes, etc. And if you run out of any one of them, the car wash is going to have to shut down. If the car wash company allows that to happen, they're going to lose significant revenue. They're going to lose days of revenue if they're waiting for chemicals to come in. They'll probably pay expedite fees to get it there as quick as possible. So all of that costs money. Car wash companies figured out years ago they cannot afford to let that happen, so most of them installed some sort of remote monitoring system for these car washes. That allows them to get maybe an email or a text alert, or maybe see some value online. And that's a good example of a simple remote monitoring system. It works well, it saves them lots of money, it's good value. But when we talk about the industrial Internet of Things, we can do far more than that, and there is value in doing far more than that. So why not let the car wash itself reorder the chemicals? It already has the data of the current tank levels, but let's look at more than that. Let's look at the historical usage by that specific car wash. How much of each chemical is being used? How much do you have left? That ought to tell you how soon you're going to run out. And if you're tying into some online ordering system like SAP, you may be able to access the lead time for that chemical, and then you can say exactly when you need to reorder. And of course, car washes are very weather dependent. Depending on whether it's sunny, cloudy, muddy, slushy, all of those things factor into how often people will be washing their cars. So that ought to be factored in as well. So you're looking at the typical usage rate based on the weather conditions that are forecast over the next 10 days from the nearest NOAA weather database station. So the benefits of doing this is less downtime, number one, because you're not going to lose revenue every time the car wash shuts down. We can avoid those shutdowns. Fewer service trips. You're filling the chemicals when they need it, not just on a routine schedule. Less on-site inventory. You don't have to stock up with multiple tanks on site if your ordering system is accurate. Also, most of these chemical suppliers have some sort of central warehouse, whether it's a car wash or some other chemical or consumable product. The OEM, if they're selling that, has to stock it. Well, if you get information from all your remote machines that you're responsible for, and you can get somewhat accurate predictions, you can truly do just-in-time ordering without risking running out at your warehouse. You also eliminate the expedite fees if you don't have to overnight things. You spend less time on order entry and fewer chances of ordering the wrong chemical or sending it to the wrong site, etc. So that's a simple example of how a remote monitoring system can evolve into something much more valuable. But what about continuous improvement? You might have a machine that says, hey, it can make, on the spec sheet, 100 parts per minute, 100 parts per hour, whatever that might be. And you say, well, it's supposed to make 100 parts per hour, or my production line's supposed to be 100 parts per hour, but in an 8-hour shift, I'm getting about 300 on average. Once we got up to 500. We've never hit 800. Well, why not? Well, the machine breaks down sometimes. At least the operators say that's the main problem. Of course, the operators might be taking longer breaks than what we realize, or taking longer to start the system up after a break. Not really sure. And then there's scrap, rework. If you got to rework products, we're losing production that way. And maybe it's not really running as fast as the OEM told us it should. We got no idea, really. So to paraphrase the quote on the left there, if you're not measuring something, it's awfully hard to improve it. It's not impossible. You know, you look at diet and exercise. You go, well, if I eat less, exercise more, I'm going to lose weight. How much? Well, I don't know. But you'll find you lose more if you're actually getting on the scale, if you're actually counting calories. Measuring things makes it easier or more likely that you're going to improve it. A lot of production line managers will put a board like the whiteboard I'm showing here just to show the different shifts. Hey, look, the shift ahead of you made this. What are you guys going to do? So when you start measuring things, there is a factor in here that people are more likely to work to improve it. But this doesn't give you nearly the granularity we need, because this doesn't tell you what your root cause of downtime is. What do I work on to make these numbers better other than just cracking a whip and trying to incentivize the shifts? Because it's not all their fault. So there are issues with the machine. There are opportunities for improvement. Let's look at how we measure those and improve. For decades now, overall equipment effectiveness, or OEE, has been considered the gold standard for continuous improvement. OEE looks at availability, which is the flip side of downtime, but availability, quality, and production rate. Production rate expressed as a percentage of the ideal, maybe the OEM spec on that machine, or all of your machines. But they're all expressed as a percentage of an ideal value, so it should in theory always equal 100% maximum, but it's a percentage of that. You multiply the three together. If you're at 85%, that's considered a world-class production facility. 60% is fairly typical. 40% is pretty common for people who just start measuring it. So getting from 40 to 60, just measuring it and hitting the obvious things can get you there fairly quickly. Getting that extra 60 to 85, you're going to have to work a little harder. But you need information, you need informed decisions in order to move up that scale. And so I just said OEE's been around for decades, so why am I talking about it now as if it's something? Well, what's new is the industrial Internet of Things have made OEE much more affordable for a much broader range of customers, whether you're an OEM trying to get data from your machines or an end user trying to do it in-house. To get OEE, a traditional in-house SCADA type solution or SCADA based solution, you're going to pay $50K to $100K in software licenses, is what I've found to be fairly typical. You also need to put it on a server. You know, if this is going to be available to a large number of people and house massive amounts of data over time, it's not running on a PC, so you're going to want to invest in some hardware. You're going to have to decide if redundancy is valuable, if power backup for your data. You know, if this is important stuff you're making, you're going to want to consider those things, an environmentally controlled data center, etc. You're going to go to school. You're going to attend a class on how to develop this software, typically 2 to 3 weeks. You're going to have to do the software installation or hire someone to do it. You're going to have to apply that software to fit your specific application. You're talking about a timeline of many months just to get the first machine up and running and producing data. Then you got ongoing software support. You have OS upgrades every time you upgrade the operating system. All that software may need to be revised to match the operating system requirements. There's ongoing troubleshooting, there's phone support, etc., etc. That is the old way of doing OEE. In the right-hand column, hosted OEE is much, much simpler. So you have to document your OEE requirements, whether you're doing it in-house or doing a hosted solution. But once you do that, you give it to the provider, and you're talking about something that's maybe 20 to 30K in configuration just to build a model of your particular production line. Now, if you got lots of different types of lines, you know, that's going to be more. You're going to add those in. But all you have to install is an edge node. You're talking about a timeline as short as a few weeks, maybe, 6 to 8 weeks, but you're not talking many, many months before you get data. And you're going to pay an online hosting fee. So the initial investment is much, much smaller, and the timeline is much, much faster. That means faster return on investment. For more details on this concept, you can download our webinar on the benefits of hosted solutions. In there, we also talk about the option of on-premise hosting, which a lot of companies are interested in. So OEE is a great idea if demand for your product is increasing, because then you can increase your throughput, then increase revenue. What if demand's not increasing for your product? Maybe you need to figure out ways to cut costs instead of increase production. Well, one way to do that is to look at maintenance costs and use predictive maintenance. I'm going to go back to the car dashboard example. What you see in the middle of the screen there is remaining oil life of 74%. So once upon a time, we were all told we should change our oil in the car every 3,000 miles. Now, cars have gotten better at this. Synthetic oil has extended that number, but it's an example of a scheduled maintenance program versus something more predictive. So where does this oil life remaining number come from on the screen? Well, a lot of cars have that now. It's based on a mathematical formula, typically includes mileage since the last oil change, temperature variations, the motor RPM. Some cars also have sensors that can actually measure the oil conductivity, or indirectly by measuring viscosity by the way it sloshes around. It's actually measuring the weight of the oil as it moves around inside the car. But you can use these numbers that are being calculated in the background continuously to come up with a remaining oil life. And then, of course, when that oil life gets low, you're going to get an alert telling you, hey, you better change the oil now. Now, prior to this, people used to have to rely on the owner's manual and just hopefully remember to change the oil at whatever interval they're told to. If you don't do that, of course, you're going to cause damage to the engine, service costs, the life of your vehicle goes down, etc. So very expensive to not change the oil. But you also have to realize that changing it on a regular interval is also expensive, because the oil life monitors are looking at how you're driving the car and saying, hey, you can make it to 8,000 based on the way you're driving the car. And it's measuring real data as to how your engine is being operated, how it's functioning, and changing the oil more often than that is actually a waste. So the scheduled maintenance is always based on a worst case scenario. Meaning, if you follow the scheduled maintenance, you're spending much more on maintenance than what you really need to. Now, industrial equipment, in many cases, it's much more expensive than your car, and in many, many cases requires a lot more maintenance than your car. But unlike your car, a lot of these machines are not getting full-time operators. You might have one operator that's responsible for a dozen machines. He's not sitting there looking at a local screen, and that local screen may not have detailed maintenance information anyway. You know, the operator may consider maintenance information more of a nuisance alarm, and he may not tell the maintenance people that need to find out about this, or may not tell the OEM. The data that you're seeing on the screen here can be available on a web page, on a smartphone app, so whoever needs that information has access to it anytime they want. And when something gets critically low, the signal turns red on the screen, but more importantly, it sends out an alert. And of course, per my previous example, that could actually schedule a maintenance call rather than sending an email that sits in someone's inbox. And much like the oil life indicator in your car, these things can be looking at motor vibration, at motor current, temperature, etc. They can look at various signals to say, hey, you got a problem here you're going to need to address. And over time, you can look at data between how long you've gone between a particular maintenance event and how the machine performed, especially if you're looking at vibration or some measurable signal like that. And you can start to predict how quickly you're going to run into trouble. That is a fairly simplistic form of predictive maintenance. Sometimes what I just described is called condition monitoring rather than true predictive maintenance. So what then is real predictive maintenance? Well, predictive maintenance can incorporate artificial intelligence. When we take artificial intelligence and apply it to industrial equipment or machines in general, that's referred to as machine learning. So over time, based on the data that you're collecting, the machine can actually get smarter. So for example, predictive maintenance, you can get to a point where after a certain number of failures, you can say, aha, based on the data pattern that I see, that I've seen over and over, I know that this component, this specific component, is going to fail in this specific number of days. That is, of course, even more valuable if you're just looking at a vibration signal and setting a threshold and saying, well, if it vibrates 20% more, a month from now than it does today, I'm going to take the machine down and service it. What you don't know is, could you have gone an extra week, an extra month with that amount of vibration, or did you really need to take it out of service? And that's what predictive maintenance is trying to get at. So that's one example of machine learning. Others are process optimization, things like an extruder or injection molding machines, things that are complicated to set up and maintain with lots of variables. Over time, you can look at the different variables through machine learning, recognize patterns, maybe recognize variable correlations within the machine, and say, aha, based on these conditions, this is the most optimum setting. And when I talk about variable correlation, maybe you tie in the relative humidity or temperature. A lot of machines are not in a controlled environment, so those can be significant variables. One of the interesting things about machine learning is it's really a mathematical calculation. The machine learning platforms that I've listed there, Amazon Machine Learning, IBM Watson, Cortana Intelligence Suite, from Amazon Web Services. Those are systems that they're looking for large amounts of data. They analyze it, they flag anomalies, they help you understand what's a critical anomaly versus a non-critical anomaly. But it's really mathematical data science expertise, not necessarily process expertise. At RRAMAC, we're not going to write our own machine learning platform, but we can leverage any of those three, or we can work with other companies that have expertise in a specific industry. Again, there's a lot of people that maybe know a packaging line inside out, or energy management, those sorts of things, where we can look to those companies and say, look, here's a platform with all the data, help us analyze the data. And so then we turn around and incorporate that as a complete solution to the customer. What those other companies are not so good at is actually understanding the factory floor equipment, connecting to it, getting data out of it, and getting you the short-term value that I've talked about as well. The point being here is we're able to take you from the simplistic low-cost systems. If that's all you're looking for today, we can help you with that. But when you're ready to do more, we can help you scale up over time. So I'm going to finish with our IIoT roadmap, and what I have is simple asset monitoring on the left-hand side. Maybe you want a handful of alarms, maybe you want a maintenance dashboard, monitoring temperature and humidity, tank level. And then as you get more intelligence from the left-hand side to the right-hand side of the screen, more intelligence, more data history, you can start to do downtime summaries. You can start to analyze production. You can do root cause analysis. What were the events leading up to this alarm failure, for example? From there, you can get to the higher level applications like OEE that I talked about in some detail, reordering consumables. And then on the high end of the scale, the actual machine learning and applying the detailed time series data analytics. The point here is to get you a roadmap where you can make money, you can get return on investment from the simple applications on the left, scale up to the longer term goals, and get continuous improvement out of your processes or continuous cost savings improvement. That's all for today. Thanks for tuning in, and please feel free to call us if you have questions or would like to discuss an application. Thanks.